everyone. Today is Friday, January 20th. And so today we will continue with the worksheets. Let's see. So to go to our recordings, so this is our Blackboard site. And if you click Tab Live, Collaborate right here, and then you can see this is the menu, and then when you click Recordings, you can see our Wednesday recordings. So this is the place you can find the recordings. Okay, so let's continue. So last time we were talking about like how to factor. A squared plus B squared cannot be factored, right? Using the real numbers coefficients. And then A squared plus 2AB plus B squared equals parentheses A plus B squared. You remember that? And A squared minus B squared equals A plus B times A minus B. A cubed plus B cubed, okay? If you see cubed, then we can factor. So the first factor, you have power 1 terms, right? A plus B. So if this is plus, then this is plus. And then the next factor, the middle term, the sign is the opposite of that. So this is minus. And then all these, they're power 2 terms, right? And the coefficients are all 1. Okay? So here you have 2AB, but here you only have 1AB. A cubed minus B cubed. That is A minus B. So if this is minus, then the first factor is minus. Right? Do you remember that, everybody? And, oh, this sign is opposite of that. So this sign is plus. Okay. So these 4 formulas, very important. Gotta memorize those. Okay. If you actually forget, you can always deduce it. Just distribute it and combine the like terms. Distribute it, cancel these 2 terms. Then you can get this formula back. Right? Okay, so last time we did part A. This is the difference of 2 squares. That's why we want to express this as something square. So 25 is 5 squared, right? And 9 is 3 squared. And 1 plus 6 is y cubed squared. Yes, do you remember that? Now, A squared minus B squared is A plus B. Your A is like 5x plus B. B is like 3y cubed. And then A minus B. So we continue. Okay. So part B. When you have 4 terms, group 2 of them together, and then the other 2 together to see whether you can factor. So let's say here, wow, let's group the first 2 together and group the last 2 together. Okay, look at these 2 terms. Can you see a common factor? X squared, right? Everybody see that? X squared is the common factor. So we factor out x squared. What's left? Y squared minus 2. Very good. Yeah, that is the first 2 terms. We can factor out x squared. How about the last 2 terms? What's the common factor? 3. Yes. So factor out 3. What's left?
Y squared.
Yeah, y squared minus 2. Oh, do you see? Here we have 2 terms. Terms are separate. Okay, so this is 1 term. It has this factor and this factor. Okay, so these 2 terms have a common factor, y squared minus 2. And now what's left?
X squared plus 3.
Yeah, x squared plus 3. Very good. can we factor further? And do you see this is y squared minus 2? But you can actually think of 2 is like square root of 2 squared. Yes, everybody? 2 is like square root of 2 square. Because if you want to factor as much as you can, right? Then if you consider 2 is square root of 2 squared, this is the difference of squares. We can factor difference of squares, right? A squared minus b squared is a plus b times a minus b. Yes? Right, everybody? So this becomes what? What's your a? Y. What's your b? Square root 2. Yes. A plus b times a minus b. Right, everybody? Can we factor a squared plus 3? If it's plus, can we factor it? No. No. Right. Yes. So this is the answer. Okay.
So the number can be square rooted.
Yes. Right. Yes. If y squared minus a number, you can still factor further. Right. Bless you. Okay. Oh, by the way, so have you learned like solve equations before? So if I say I wanna, for example, I want to solve this equation. So set this guy equal to 0. How do you solve it? Well then, if you can factor it like this, you set it equal to 0. And then you set each factor equal to 0. Right? So you have, y plus square root of 2 is 0, or y minus square root of 2 is 0, or x squared plus 3 is 0. Well then, here, you solve for y. Y would be negative square root of 2. Here you solve for y. You add square root of 2 on both sides, right? So you get y equals square root of 2. And x squared plus 3 is 0. Impossible. Because x squared is always greater or equal to 0. So you add 3 greater or equal to 3. It won't be 0. So therefore, if you want to solve this equation, and these are the solutions. Okay, everybody? Yeah, so factoring is very important. It can help us to solve equations. Okay, keep going. How about this problem? Okay. Alright, so we only have this problem. We want to factor it. But because of the 1, that's weird. So maybe we should expand it and see what can we do with the 1. Maybe we can combine some like terms. Right, everybody? So expand it. Well, this is a complete square, right? Oh, by the way, a plus b squared is a squared plus 2ab plus b squared. And then a minus b squared is a squared minus 2ab plus b squared. Right? You just change the sign of the middle term. So that's why here a squared minus b squared equals a squared minus 2ab plus b squared. Yes, everybody? So this is like a, this is like b, so a squared, y cubed squared, minus 2a, a is y cubed, b is 1 over 4y cubed, plus b squared, b is 1 over 4y cubed squared, yeah? And then we add 1 at the end. Okay, that's the attendance alarm, right? So yeah, the attendance, 10 minutes after the class. Okay, all right. Let's see. Can you see here y cube and y cube? We can, right? And can you see 2 and 4? We can cancel the 2. What's that in the denominator? 2. Yes. Okay, this cancel, we get 2. So this term is actually 1/2. Right? Everybody? This term is 1/2. Oh, negative 1/2 plus 1 is 1/2, exactly. So we get y cubed squared plus 1/2 plus 1 over 4y cubed squared. Okay, you might ask, why don't we put y to the 6 here? Why do we keep it like this? Well, because we want to vector it. Our goal is to vector it. Yes? Okay. Now, let's compare. Maybe let me write down the formula again here. So, compare a minus b squared. That's a squared minus 2ab plus b squared. Also, compare a plus b squared. That is a squared plus 2ab plus b squared. Right, everybody? Now, look at this guy. This is a minus b squared, right? I want you to compare these terms. I want you to compare these 3 terms and these 3 terms. Yes.
So I'm kind of confused at like kind of like the top.
The top?
With the, I get the y3 to the exponent of 2, but it's the minus right there that's not
Oh,
right.
because this is minus. So this is minus.
So like
here, this is minus, and this is minus.
Okay.
If this is plus, then this is plus.
Okay, so but when we like use that 2 for the 4, that kind of threw me.
The 2?
Yeah.
This 2 is like the 2ab, the 2. And then this 4 is from the b. So 2 and the 4, we can cancel the 2. Because 4 is like 2 times 2.
Yeah.
So we cancel 1 copy of the 2, but we still have 1 copy of the 2 in the denominator. That's why this term, after we simplify, this is 1/2.
Okay.
And it's negative 1/2. Oh, but because of this 1 minus 1/2 is 1/2.
Okay.
So therefore, I want you to compare these 3 terms and these 3 terms. Do you see the first term are the same? And do you see the second term? The number, the value is the same, but the sign is opposite. The last term is the same, right? Okay, look at this formula. A squared, same. 2ab, but the sign is opposite. The third term, b squared, they're the same. So, can you recognize this? This guy is actually the complete square of a plus b squared. Can you see that? So, what is a plus b? It's exactly this guy, but you replace the minus sign by plus. Yeah? We compare. First term, the same. Middle term, opposite sign. Third term, the same. Then it's complete square, but the sign changed. Therefore, this is A. What's A again? A is y cubed, right? Plus b. 1 over 4y cubed square. So this is how we factor it. We recognize this is the complete square of that. Yes. So this example now is harder.
So how do how do we cancel the half?
How do we cancel the f?
The half, like
The half. The half?
Yeah,
oh, this is negative 1 half. Negative 1 half plus 1
right.
is 1 half.
Right.
We're not canceling. This is complete square. Okay, so a plus b squared is not a squared plus b squared. Do you see this square is outside of the parentheses? Yes. So the 2ab is here. The 1 half is here. Thanks to that 1 half. These equals to the complete square. Complete square is not the sum of two squares. It's the parentheses a plus b squared. We have the parentheses here. Yes. So very important. A plus b squared is not equal to a squared plus b squared. A squared plus b squared cannot be factored. You know that, right? And parentheses a plus b squared is actually a squared plus the 2ab. We have an extra term 2ab there. So yeah, these two is very easy to get confused. Be careful with that. Alright, everybody? Okay. So keep going. Yes. So you have homework problems like these, so practice those. Okay.
The
Yes.
answer is y3 plus 1
over
y.
4y squared. Yes, this is the factor.
All right.
Yeah. Okay. So and then continue exponents and radical. So a to the n times a to the n is a to the n plus n. Do you remember that? We add the exponents. A to the m over a to the n is a to the m minus n. We subtract the exponents, right? And 1 over a to the n. So if you move it upstairs, your exponents become minus. A to the 0 is 1. As long as a is non-zero, and I can tell you, even though an a is 0, this is also true. So 0 to the 0 is by definition. So 0 to the 0 is by definition 1. Okay, so by definition, just assume it. Okay? It's like, oh, why 1 plus 1 is 2? We just call it 2. Right? So 0 to the 0 by definition is 1. So then this is true for all a. Okay. And next one, a times b to the m equals a to the m times b to the m. So for multiplication, you can distribute the power. And now, be careful. A plus b to the m is not equal a to the m plus b to the m. When you have addition, can you distribute the power? No. Simply, for example, this one. A plus b squared. Can you distribute the square? No. See, they're not equal. You have the 2ab there. Right? So in general, if you have sum or difference, okay, if you have sum or difference, you cannot just distribute the power. Okay, you can only do that if you have multiplication or division. Then you can distribute the power. Is that clear, everybody? And then a to the m to the n is a to the m times n. Sorry, last time it rained, I pressed the button wrong, so it rained another 9 minutes. Okay, and then radical a to the 1 over n. This is the nth root of a. Yes. And then, oh, do I mean this one? Yeah, a squared and then square root is actually equals to absolute value of a. You might ask, why? Two. Negative 2 squared, and then we take square roots. What do we get? What's negative 2 squared? 4, right? Do we have negative 4? No, because negative 1 squared is 1. Yes, everybody? So this is 4. So that is 4 inside the square root. Now, what is square root of 4? 2. You see? We get 2. We don't get negative 2. Therefore, when you see a squared and then square root, this is not just a. It's always greater or equal to 0. Okay? So you can think of 2 is like absolute value of negative 2. So therefore, square root of a squared is actually absolute value of a. It's not just a. Okay, it equals to a if a is greater or equal to 0. But if a is negative, it actually equals to negative a. Because when a is negative, the negative a will be positive. Yeah. Okay. How about square root of a squared? What's this thing? Well, you get a. But think about, do you remember when we talk about square roots? Square root, we require the things inside the square root must be greater or equal to 0. So as long as you use square root of some terms, then we automatically think that the things inside the square root has to be greater or equal to 0. So here, as long as you see this expression, we will already assume the domain. Okay, the possible value for the expression a, it has to be greater or equal to 0. So that's why it's okay to say this is a, because a we know is greater or equal to 0. But if you see this, a could be anything. It could be positive, it could be 0, it could be negative. All defined. All right. Yes. And then, oh, this is m over n. The n represents the n roots. The m is the power. Right, everybody? Okay. All right. So example 1. Simplify 9 to the 3/2. Okay. So yeah, from now on, try not to use your calculator in your homework. So after you finish, you can use your calculator to check the work. But when you do your homework, try not to use your calculator because you want to be of the sense of numbers. When you see 9, what's 9? 3. What power? 3 squared. Exactly. Your calculator won't tell you 9 equals 3 squared. But you can think, okay, 9 is 3 squared. So 9 is 3 squared. So you replace the 9 by 3 squared. Right, everybody? Now, oh, look at this root. 3 squared to the power of 3 over 2. What do you do to the exponents? We multiply. Yes. We multiply. What happened? Yeah, 2 cancel. 3 cube. What's 3 cube? 27. Yes. Okay. Okay, let's review. 2 square is 4. 3 square 9. 4 square 16. 5 square 25. 6 square 36. 7 square 29. 8 square 64. 9 square 81. 10 square 100. 11 square 121. 12 square 144. 13 square 169. 169. 14 square 196. 169. 196. We switch. And 15 square 295. 16 square. I don't remember that as well. Is it 280? What? Okay. I don't remember that as well. Okay. So yes, it's good to like practice build a sense of numbers, right? Okay. And 256, right? 256 and 17 square. Is it 289? Okay, yeah. How about let's use our calculator. Okay, 17 times 17. Yes, 289. 18 times 18, 324. 19 times 19, 361. Okay, but usually we won't go that far. It's too big. Okay, example 2. Simplify each of the following. 3 squared is 9. Parentheses, negative 3 squared is still 9. Yeah. How about this one? No parentheses. Huh? Negative 9. Exactly. Negative 9. Oh, because the negative stays here. Do you see the difference between this guy and this guy?
Oh.
Yeah, with the parentheses, you actually think of this is like minus 1 squared times 3 squared. So minus 1 squared become 1. Right, everybody? But here, this minus 1 just stay here. Yeah, no
It's
extra.
like negative 1 times.
Yeah, negative 1 times negative 1 is become positive 1. Yes. Okay, how about this guy? 9 what? 1/9. Exactly. Because of that negative, this is 1/9. How about this one? Yeah. 1/9 is the same as negative 1/9. Yeah. Okay, so make sure you know the difference among them. Okay, everybody? So the parentheses is very, and where the negative goes, on top or in front or inside the parentheses, also matters. Okay, let's keep going. Which of the following can be simplified? Okay. So square root is like this guy to the power of 1/2. Do you agree? Yeah. So this is like to the power of 1/2. We say that we can distribute the power if this is the multiplication or division. But if this is a summation or subtraction, can we distribute the power? No. Okay, so therefore, when we have products, we can distribute it. Yes, everybody? Mm-hmm. Oh, and then what's square root of a squared? A with a absolute value. Yeah, and here B with the absolute value. Right, everybody? Okay, if we have sum, can we distribute the power? No. So this one can be simplified. So this is not equal to square root of a squared plus square root of b squared, which is a plus b. So this is not equal to a plus b because this is sum. We cannot distribute the power. Okay, everybody? Yes, this is very, very important. Okay, good. Any questions so far? All good? Yeah? Okay. All right, more practice. Simplify each of the following. Okay, so when you see this expressions with constant term, variable x and variable y, the first thing you do is group them. Group the constant term together, group the x power term together, and group the y power term together. Okay? So let's see. What are the constants? Here we have 2 is the constant. And then here the constant is -1. Right, everybody? So the constant you can think of as like 2 and -1. And these are the constants. Okay? And now, how about the x power? X to the -2. Right? Here, x to the 4. X to the 4. So these are the X. Okay. How about Y? What do you get from here? Y cubed. Here? Y. Right, everybody? So this is X power. And this is the Y power. Okay. So we group them. Okay. 2 times -1 is -2. Okay. X to the -2 times X to the 4. What do you do with the exponents? You add them or multiply them? Add them. So -2 plus 4. Yes? Let's do it slowly. And here, what do you do? We 3 plus 1, right? Okay. X to the
-6. No.
-2 plus 4 is x to the square, right? Yeah, right? Okay, and then y to the 4, yes. Right, everybody? Okay, keep going. Part B. So part B, you can calculate the inside first and then everything raised to the power square. Or you distribute the square to each term and then calculate that. Which way is easier? Do the inside first and then raise to the power 2, or distribute inside first? Yes, that's easier. Okay. So sometimes there are many different ways to solve a problem. Some way may be faster, and some way is longer and harder and more work. It's good to compare which way is easier before you actually start. Okay. Yeah, do the inside first. Okay. Constant 3. X power 4 minus 2. Yes, everybody? If it's in the numerator, the 4. If it's in the denominator, we subtract the exponents. Right, everybody? How about the y? Yeah, -3. Very good. Okay, let's do it slowly, step by step. 4 minus 2 is 2. And y to the -3. Okay. Now, can we distribute the power 2? Yes or no? Is it a product or sum?
Yeah.
Product, yes. We can do it. If we have sum, we cannot do it. Okay, but if it's product, we can do it. If it's sum, we 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 use the formula a squared plus 2ab plus b squared. Okay. Yes.
So like, what do we put into like each one?
Yes, exactly. We put each one. This is what I mean by distributes. So this is like 3 squared, x squared square, y -3 square. Yeah. What's 3 square? 9. What's x square square? X to the 4. And how do you get a 4? You're doing 2 times 2. So even though 2 plus 2 also give you 4, but here is actually 2 times 2. And y to the -6. Yes, that is -3 times 2. That gives you -6. Okay, so this is a simplified version. I know your previous class, maybe your professor will let you to move this in the denominator and put y to the 6, but I prefer this. Okay, I prefer this format. Yeah. Just leave the negative exponent there. Don't write down the denominator. Okay. All right. So keep going. Square root of 75. That's why don't rely on your calculator. Because if you put square square root of 75, it just gives you a decimal. But this is not what we want here. Here, simplify. We don't want decimals. We want to have an exact answer. Okay? First, let's figure out what's 75. Okay. And remember, when you look at a number, you look at the last digits. If the last digit is a even number like 0, 2, 4, 6, 8, then you know it's divisible by 2, right? And how about 3? When do you divisible by 3? When you add the digits, that number is divisible by 3, right? Do you remember that? Mm-hmm. Let's look at this. 7, look at the digits. 7 and 5, right? 7 plus 5 is 12. 12 is divisible by 3. So 75 is divisible by 3. Okay, so if you want to write down all the factors of 75, is it divisible by 2? No, 5 is the odd digits, right? It's divisible by 3. And then, so 3 times 2 is 6. Yeah. And 7 minus 6 is 1. 1, 1, 5, 15. 15 is 3 times 5. Yeah, 25. And you look at the last digit. If the last digit is 5 or 0, then you know that number is divisible by 5. So 25 is 5 times 5. Is this how you is this how you get the factors? Mm-hmm. So I know some of you might have different notations, but it's okay. Okay, so 75 is 3 times 5 squared. Yeah, everybody? X cubed. Let's rewrite x cubed as x times x squared. Why do we want to do that? Because this is square roots. Square roots, if you see square, you can move it outside of the square roots and cancel the square roots. Right, everybody? So that's why you want to split x cubed to be x and x squared. So here, let's assume that x is greater or equal to 0. Then we don't need to worry about absolute value or something like that. Let's assume that. Okay, now, because this is a product, we can distribute the square roots. Square root of 3, square root of 5 squared, square root of x, square root of x squared. Yeah, we distribute the square roots. Square root of 3, you cannot go further. Square root of 3 is square root of 3. And if you plug in the calculator, it's 1.732 something. But we don't want to use your calculator. We don't want a decimal. We want exact answer. So just leave it as square root of 3. What's square root of 5 squared? Yeah, that's 5. Square root of x, square root of x, square root of x squared, x. So now you combine the factor without the square root term. So that's 5x. And then you combine the factors with the square roots. So this is the answer. So 5x, no square root. 3x has a square root. Okay. Yes. So therefore, your calculator is not useful. Maybe it can help you to confirm, 75 divided by 3 is 25, 25 divided by 5 is 5. It can help you confirm that. But still, don't fucking square root of 75. It does not help. Okay. Good. Okay, keep going. See, our problem's getting more and more complicated. But we use similar methods, right? We combine the coefficients, constants, coefficients, and then we combine the x powers and the y powers. Okay, what are the coefficients? We have, what's the coefficient in the first factor? 4. In the second factor, -3. So 4 times -3. That's the coefficients. X power. What the x power in the first factor? X squared. Second factor. X to the negative 1/3. Good. How about the y? Y to the what power? 3/2. And y to the negative 3/5. Okay, so we write out the coefficients, the x powers and the y powers. Now we can simplify. 4 times negative 3 is negative 12. Okay, x. We combine the exponents. Do we multiply them or add them? Add them. Yes. So 2 and negative 1/3. Yeah, it's the same as 2 minus 1/3. And then y to the 3/2 minus 5/5. Okay. What do? Common denominator, right? Look at this guy. 2 minus 1/3. What's the common denominator? A. This 2 is in the numerator, right? So the first term, you don't have any denominator. Second, 3, denominator 3. So therefore, the common denominator is 3. So you can think of this is 1, this is 3. So this is 2, this is not 1/2. So the denominator is like 1. So 1 and 3, the common denominator is 3. How do you get 3? You multiply by 3 on top and the bottom, right? So you multiply 3 here, 3 here. You get 2 times 3 is 6/3 minus 1/3 is 5. So negative 1, negative 12, x to the 5/3. Yes, everybody? Okay, how about these ones? What's the common denominator? 10. First term, we multiply by 5 on top and bottom. Second term, we multiply by what? 2. Okay, so now we have 10 in the denominator. 3 times 5 is 15 minus 3 times 2, 6. 15 minus 6, 9/10. Yes. So this is y to the 9/10. Questions?
So do you want us to keep the fractions as improper or mixed numbers?
Yeah, just leave it like that. Improper is fine.
Okay.
Yes, I prefer improper. Right. Okay. Yeah, thank you for asking. All right. So we keep going because for the proper ones, it's very easy to confuse with the multiplication. So sometimes you get 2 and 1/3. Well, it looks like 2 times 1/3. So if your paper is dirty, the dot might be there. It's confusing, right? So yeah, I prefer improper. Yeah. Okay. Any questions so far? Are we all good? All right. Bless you. Okay. Do you still remember factoring? Trinomials. Okay. Let's practice. Okay. So simplify each of the following rational expressions. Okay. So first of all, I would say so we order the terms. So you have the highest power first, and then the lower power and do the constant. Okay, so first step, reorder it. Okay, so you get the highest power and then go down to the constant term. So in your numerator, reorder it. Do you see we get negative x squared plus x plus 12? Denominator is already in a good order. So we just keep it. Yeah, everybody? So that's first step, reorder it. Second step, make sure your leading coefficient is positive. If your leading coefficient is not positive, factor it. So if leading coefficients, do you know what's leading coefficients? It's the coefficients of the highest power term. So in this case, the high power term is negative a squared. The leading coefficient is minus 1. Yes, everybody? Okay. And then here, the leading coefficient is 2. Exactly. So if leading coefficient is negative, we factor the negative 1. So therefore, numerator, factor the negative 1. What's left? X squared. Yeah, very good. Denominator, keep it. Okay. So get things ready. Now they're in the good order, and now the leading coefficients are positive. Okay. All right. Now let's start. Okay. Let me use how about orange color? Okay. How do we factor this? Some of you might learn like different ways or different notations. Okay. So let's do the x squared minus x minus 12 here, and let's do the 2x squared minus 9x plus 4 here, and then after we factor down, we put the answer here. Okay, let's just break it down into smaller parts. How do we factor this? Okay, so one of the notations says you put parentheses. Okay, and look at the first term, x squared. The factors of x squared, it must be x and x. No other choices. Right, everybody? X and x. So you put an x here, you put another x here. Okay? Now, how many of you are using this notation when you learn the factoring? Okay. All right. And then you look at the constant term. It's negative 12. Negative 12, what are the possible factors? It could be, how about, let's say 12 first. Okay, 12. What are the possible factors of 12? It could be 1 and 12, 2 and 6, 3 and 4, right? 4 and 3 is similar to 3 and 4. And because of negative, which means one of them is negative. Right, everybody? So you can have negative 1, 12, 1 negative 12, negative 2, 6, 2 negative 6, negative 3, 4, or 3 negative 4. Yes, everybody? And we put different possibilities here until you, so let's try. Let's try 1 and 12. Okay. Let's try 1 and 12. We know one of them is negative. Let's put negative here and here. Then you see, oh, 12 times x is 12x. Here is negative x. When you add them together, you get 11x. That's not negative x, right? Therefore, we know. And also, if I switch the sign, you get negative 11x, still too big, right? Therefore, not this pair. And do you see this is negative 1x? 2 and 6 won't give you negative 1. So 6 minus 2 is 4. It won't give you 1, right? So 3 and 4 will give you 1. So therefore, we use 3 and 4. Okay, so 3 and 4. And because this is negative, where do you put the minus sign? On the 3 or on the 4? Negative 4, exactly. Now when you multiply them, you get negative 4x and 3x. And you add them together, you get negative 1. Okay? And I know some of you might use the notation xx and 3, negative 4, and you do like plus multiply. Okay? Yeah, some of you might use this notation. Okay, we continue on Monday. Okay, so please review factoring. Okay. Yeah, we will continue. Have a nice weekend. Oh, if you have filled that form, your schedule, yeah, please submit here.
So we assume X. Assume that.
When you have like square roots, you kind of assume that.
Okay, cool. Okay, thank you.
Thank you.
Yeah, thank you.
Have a nice weekend. Thank you.